Welcome to the 8th of 14 videos on the Arc Flash Truth No One Explains. My name is Joe Chacon. I'm the president of Podge LLC and Chacon Engineering. I'm a licensed professional engineer in multiple states and have been an electrical engineer for almost 30 years. Please like and subscribe as this helps us get this important information in front of more people. This video is going to talk about how to calculate arc flash boundaries. The arc flash boundary is the distance from an arc where incident energy will be 1.2 calories per centimeter squared. In our previous video, we calculated incident energy. We're going to stay with that same example, and you shall recall that example was an enclosure 508 millimeters by 508 millimeters by 508 millimeters, deemed by definition to be typical and not shallow. The working distance is 18 inches. The bolted fault current is 60 kiloamps. The voltage is 690 volts. The clearing time is 200 milliseconds. And the electrode gap or bus bar gap is 1 inch or 25 millimeters. And the bus bar configuration is all vertical, called VCB. An arc flash boundary is done the same way as incident energy is done. We calculate three intermediate values, first called AFB 600, AFB 2700, and AFB 14,300. We then use some interpolation to calculate the actual arc flash boundary. Recall table 3, 4, and 5 from our previous video that had all the coefficients. Let's look at AFB 600, the first intermediate arc flash boundary equation. Notice the equation is similar to E600. The result is 2,661 millimeters or 104.8 inches. This is the AFB 2700 intermediate arc flash boundary equation. The result is 3,895 millimeters or 153.3 inches. Finally, this is the AFB 14,300 intermediate arc flash boundary equation. The result is 4,137 millimeters or 162.9 inches. The next step is to interpolate these intermediate values to get a final arc flash boundary. These equations tell us how to do that. That result is 2,762 millimeters or 108.8 inches. Now we need to apply the arcing current variation correction factor. This will enable us to calculate the final arc flash boundary. Recall that we need to update the true arcing current called IArcmin. Please look back at that video for reference. We calculated the IArcmin to be 35.687 Ka in the previous video, and then looked at the overcurrent protected device and pulled in the clearing time, which was 225 milliseconds. Recall, we expected this updated IArcmin to make the clearing time slower, and it did. The next thing we need to do now for arc flash boundary is take IARC 600 min, IARC 2700 min, IARC 14,300 min values to update our arc flash boundary equations. Those equations are exactly the same, except we plug in IARC 600 min instead of IARC 600, IARC 2700 min instead of IARC 2700, and IARC 14,300 min instead of IARC 14,300. These give us an updated arc flash boundary for AFB 600 to be 1,973 millimeters, AFB 2700 to be 3,421 millimeters, and AFB 14,300 to be 4,556 millimeters, respectively. We need to interpolate these values to get AFB or arc flash boundary. This equation gives the value of 2,086 millimeters or 82.1 inches. In this particular case, the applied arcing current variation correction factor reduces the arc flash boundary, but that is not always the case. So also recall from video 7, we calculated incident energy to be 15.33 calories per centimeter squared. And from this video, the arc flash boundary we calculated to be 82.1 inches. These two values will go on our arc flash label along with the other minimum language required. So let's review the process one more time for medium voltage. Number 1, calculate the intermediate arcing currents IARC 600, IARC 2700, and IARC 14,300. Number 2, to determine the overcurrent protected device clearing time in milliseconds based off interpolating IARC 600, IARC 2700, and IARC 14,300. Number 3, calculate the enclosure corrections, EES and CF. Number 4, calculate the intermediate incident arc flash boundaries, AFB 600, AFB 2700, and AFB 14,300. Number 5, calculate the arcing current variation correction factor. Number 6, recalculate the intermediate arcing currents, IARC 600 min, IARC 2700 min, IARC 14,300 min by applying the arcing current variation correction factor. Number 7, determine the true overcurrent protective device clearing time in milliseconds based on the update IARC min and interpolating IARC 600 min, IARC 2700 min, and IARC 14,300 min. Number 8, recalculate the intermediate arc flash boundaries AFP 600, AFP 2700, and AFP 14,300 with the updated clearing times and IARC 600 min, IARC 2700 min, and IARC 14,300 min. Number 9, interpolate the actual arc flash boundary from the recalculated AFP 600, AFP 2700, and AFP 14,300. The next video is going to address DC arc flash calculations, which are not covered by IEEE 1584. I do a lot of DC calculations for the PV and battery storage space.